Okay. This is a reply.
Yeah, this is a reply.
Same nothing.
Yeah.
Not necessary to stop the file. Yeah, lor.
Every time I have to type in the whole sunfire.com.nes.edu.edu.
How about you try the other software?
Putty, is it?
Putty. Does it work?
Yeah.
Oh, there's a new version of SSH that called, even on the lab PC, there's something called the red color icon. The new terminal software they use to connect to server. I can't remember the name. I'm used to SSH because I use it for a long time. No, I can't remember. XFTP, something like that. Have a similar. Next time I show you lah. Okay.
Thank you, bro.
Okay. Wow, your lecture is 4 o'clock, right?
Yeah.
No, it's already 4 o'clock, right?
Yeah. Exactly.
Yeah, it's okay.
How many students do you have?
214 in the end.
240.
214.
214.
Okay, a little bit of announcements first. So for the project, I've already processed all the project group allocation. It's on project folder in Luminous. There were 3 groups. They requested for 5 members. Unfortunately, we have to break one of you. And it was chosen randomly. Okay, so there are 2 groups with 5 people. The reason is because we have 214 people. So 2 people couldn't get any place. All right, so rather than making a group of 2 or 3 people, I'm just putting, so I'll just let the 5, the group of 5. And marking assignment 1 is still in progress and is progressing very, very slowly because many of you are not following the format specified. Okay? It's just 1 mark. I don't know, maybe there'll be a half a mark or something, but I think I'm just going to look at your code whether it can solve the problem or not. Because it's just 1 mark, there's no point in penalizing it much. There's also an open help session for this week. I try not to have it in the evening, and fortunately I still managed to book for seminar room 10 So that's the only place available in the afternoon. It's from 3 to 5. Okay, so last week we kind of stopped in the middle. So we're trying to continue that before we go into the ER diagram. So this is still on lecture 3, but on the second part of the lecture. So last week we have this. The table creation, we managed to create a table with this particular syntax. Some of the constraint checking, I color-coded it. If it's a column constraint, it will be orange. If it's a table constraint, it will be blue. For some of them, there's no equivalence on the column constraint, or even if there is, it's kind of about the same. So there's just slight differences, but the main keywords are actually listed here. If you want to know more, you can look up the lecture notes again. This part in particular, the one on delete and or on update, this is color-coded as black because it can be used on both column constraint and table constraint. So the main difference being that the column constraint only look at that particular column or attributes. Table constraint look at the entire table. So if you need to have a constraint that requires multiple attributes, then you will need a table constraint. Okay, so for instance, if you want a unique pair spans multiple attributes, so you need to use the table constraint variance. So that's a table creation. We're going to look at the next one, which is after we are able to create our table, we want to be able to modify our table. The kind of modification that we want to look at here is not changing the definition of the table yet. What we want to look at for now is whether you can insert something into the table, remove something from the table, or just update the content of the table. So there's a few things here. To insert, the keyword is insert into. And then you have an optional column name. This part is the column name, and that basically just lists down, either you list down all the attributes, or you can rearrange the attributes, or you can only include some of the attributes. If you only include some of the attributes, then you will need to have the default value. Okay, some of them, if you don't specify what the value is, they're going to be given the default value. Okay, you can give a default value for a particular column by using this default. So I'll show you an example of what kind of default value we can give. If you want to remove an element from the table, the syntax is delete from. You're deleting values from the table. The where condition simply specifies what kind of conditions, which values you want to remove. Okay? If the value match that particular condition, it will be removed from the table. And notice that it's optional. It is optional as it is enclosed within the square bracket. So you can choose not to give it. If you're not giving any conditions, then the default is true. You're deleting everything from the table. The last kind of modification is to update the values. Okay, so you can update certain values from the table using the update keywords. You set the value to something. Okay? And then again, you can specify a condition. Now, for these two, because these are optionals, again, if they're not specified, it means that you either delete everything or you update everything. if you want to simply delete a single value or update a single value, a single tuple, what you need to do is you need to give the primary key or the candidate key. Okay, so those are the three syntax. So let's go into the example. The example is a continuing example. So we start with a table creation. Okay, when you create a table, such as this, notice that the student ID is the primary key. And now we have a default department. Okay, so this will be important later. We start with an empty table. So the empty table over here, which does not have any values at all. And we can insert into this. To insert, simply use this statement. Okay? So now the value is inserted. Notice that for this particular insert, I did not specify the columns. So in between here, there's no specification of columns. If I did not specify any columns, it means that, okay, so this is supposed to be columns. Because I did not specify any of the columns, it means that this value must match the column as specified in the table creation. Okay, so 1, 2, 3, 4, 5 must match with the primary key over here. Alice must match with the name over here. And the engineering must match with this. All right? So now that value is added in. So any questions? Okay, another kind of insertion will be something like this. Now I am specifying something. I am specifying which column that this value corresponds to. Okay, because I only specify one of them. I only specify the student ID over here. Name is not specified as anything, so name will be null. Because it is not specified at all. And because I did not specify the department as well, but the department has a default value, it will take that default value. Okay? So any questions? That's insertion. If you want to insert this, okay, so again, I'm only specifying the student ID. And the student ID is 1, 2, 3, 4, 5. This one, unfortunately, will not go through because 1, 2, 3, 4, 5 is already there. And again, because we specify that the student ID is the primary key, there will not be any duplicates of primary key. So yeah, this means that this SQL query is actually invalid. Okay, if you try to run it, so let's try this. Is it too small? Let me increase the size. 28. Okay, so that's your PSQL. If you get something like this, just keep on pressing enter until. So I'm just logging in with the default configuration. And the password is, let me remember, I think. Okay, good. So that example should be somewhere. This is table modification. So let's just copy this. Okay, so the table is created. So let's put it at the top like this. Okay, so let's do this one by one. These two will these two are fine. Okay, so you can already insert this. If you also look at the table, list of table, you will see that a lot of these are there. What did I create? Students. Okay, so student is there. Okay, because of the create table. Now if I try to insert this, then you will get this kind of error. Okay, because primary key cannot be duplicated. Any questions? Okay, so that's table modification. Let's see if I can actually not go into the mode. Okay, so now we can also try to insert something else again. If you insert Bob here from engineering, you will get something like this. This is the table. Okay, and to show you, so we're going to skip a little bit because we haven't gone into the SQL query yet, but I'm going to show you how it will look like when the tables are displayed on SQL. So this is a simple example of an SQL query. So you will see that there exists such a table, and it kind of match our table at the bottom over here. Okay, so the next one is this. So table modification, you add Bob from engineering. You can also add Carol from math department. And again, this is the part where I told you can actually rearrange the attributes. Okay, so instead of using the default configuration, so student ID first, followed by name, followed by department, I can actually rearrange my input such that the department comes first. Okay, so this is math. And then Carol will be the name, and the student ID will be this. Okay, so if you try this, okay, so let's try this too. Okay, so Carol will be inserted as well. Then if you look at it, you will see that there's Carol. Okay, now there's also another reason why I'm giving you the SQL code in a separate file is because if you try to copy this, it will not work simply because there's this symbol. Again, that symbol is not a quotation mark. Well, it's not a quote, a single quote. Okay, it's a stylized version of it. It's not. It is different from this one. Okay, because this one is kind of straight, and that one is kind of curved. And again, that happens because this is a kind of a rich text. So if you try to copy this, you will find that it's indeed different. Okay, so if you just try to copy it from the lecture notes, you will not be able to run it. Okay, that's insertion. Then we can try to delete. Okay, so what does this deletion mean? Okay, so this deletion, you're just going to delete from that table student, and then you're going to find everyone from the engineering department. In this particular instance, there are only two people from the engineering department, Alice and Bob. So those two will be removed. So again, I can show you here. Okay, so you notice that there's this delete 2, which means that 2 entries are deleted. And if you try to do the selection, you will see that only these two will remain. Only those people who are not from engineering will remain. Okay, so this will be the end result of that deletion. And again, last one is that what happens if I delete from here? Okay, so if you don't specify the condition will be specified as true. Because if it's specified as true, then you basically erase every entries from the table. So you can try delete from students. Then you delete 2. Okay, if I redo this with some insertion, so let me. I'm just also going to show you something else again. You can actually insert multiple values in the same SQL code. Okay, so let's say 1, 2, 3, 4, 5, Alice, engineering. If you want to insert more, you can just follow by comma. Yeah, and then 2, 3, 4, 5, 6. Now, I think this one is CS. We try not to insert the duplicate value, so 3, 4, 5, 6, 7, Bob, engineering, and 4, 5, 6, 7, 8, Carol from math. And then once you're done, you end it with a semicolon. Okay, so now 4 entries are inserted. Okay, if you select, you'll get all 4 of them inside. And if you delete again, if you do this deletion without any conditions specified, then what you will get is the table will be empty because you have just deleted 4 entries. All the entries inside. So let's try this, then you get empty. Okay? So any questions? Okay, so this one is basically just remove everything. Okay, so I'm just reinserting 2 values because at the next query, what I'm going to show you is update. Okay, so let's look at this update. Let's have this insertion first. So these are the content of my table. If I do an update, my first update here, I'm going to set the name as Bob for every entry such that the department is CS. If there are multiple entries with CS department, then all of them will be updated. However, as you see from here, there's only 1 entry with CS department. So that will be updated to have a name Bob. Okay? If you want to update everyone, this is what you can do. Okay, so you will see this. This means that you update the student ID, you increment it by 1 for everyone because you do not specify the condition. Okay, so remember this. The student ID was initially 1, 2, 3, 4, 5 and 2, 3, 4, 5, 6. After you update, you will get 1, 2, 3, 4, 6 and 2, 3, 4, 5, 7. Okay? So any questions? Those are the 3 types of table modification. So let's continue on over here. Okay, so once you can modify the table, you can insert, you can remove elements from it, you can delete the entire table. or you can drop the entire table. You can also update entries in the table. We can also modify the definition of the table. Okay, so these are what you can do. So I'm not going to go into details on this. The keyword here is alter table. The keyword here is alter table. Okay, you are modifying the definition of the table. Okay, what you can do is you can add a column. You can drop a column. Okay, or you can alter the column itself. Here what we do is we drop the default. So there's no more default for the department after this. Okay, so any questions on this? So yeah, that's basically about the modification of table. Okay, so you can create table, you can drop the entire table, you can remove elements from the table, you can insert into the table, and you can update entries in the table. Any questions first? The next part that we're going to go through is about queries. So how you can ask things from the table. So at this point, what we can say about the table is that because the entries in the table satisfies all the integrity constraints, you can think of it as a fact. Okay? They are a known fact. So from this known fact, can you gather information about things that you want to know? Okay? The simplest things that you can know is that what are all the facts. Right? So you need to kind of model your table such that the data that you have inside corresponds to a fact, and the relationship between the data captures kind of a knowledge. So let's take a look at the syntax first. The most basic syntax will be the SQL query with 3 clauses. Okay, so you've seen this before. There's something that is even simpler. You select something from something. The where clause is optional again. Select here, you will just select the attributes. From is the tables that you want to look at, and where is the conditions that must be satisfied for it to be displayed. Okay, so yeah, that's basically what I've just said. Now the select list will just basically all the columns, all the attributes. You can rearrange it if you want, or you can say that you want everything. Everything you can be specified as a star. The output of this will be a relation. So again, relation will be a set containing the tuples, but it must satisfy the condition. Okay, there is this thing called distinct. So unlike the relational algebra that we use, where the relation is a set, here in SQL it is kind of a multi-set. You may have duplicates. I mean, if you don't have any primary key, then you may have duplicates. But if you have primary key, then you cannot have duplicates on the primary key. Right? So there's a slight difference between the relational algebra definition and the SQL implementation. So yeah, so that's the very basic syntax. So you have select something from something where something. Okay, so we can use this as a kind of some concrete example. Okay, still not fully concrete, but it is more concrete. So you can actually do something like this, where you have selection, a kind of almost actual selection. This A here, A1 to AM, will be your attributes, your set of attributes. R1 to Rn will be all your tables. and C will be your condition. Okay, if you have something of this form, it will map nicely into this relational algebra. Okay, so if you still remember what it is, you have the projection, you have the selection, and you have the cross product. Okay, so let's look at the relational algebra form slowly. So on the left side, you have projection. Okay, so projection pi here, unfortunately, kind of corresponds to your select keyword. Okay, I know we have the selection in the relational algebra, but unfortunately, that does not correspond to the select clause. The select clause actually corresponds to the where. The selection in relational algebra corresponds to the where clause. Okay? And your cross product corresponds to the from. So if you specify a lot of tables, what you will do is you will do a cross product on all those tables that you listed. The intermediate form may be very, very large, but that is for the DBMS to handle. Okay, so this is everything. Notice that we are missing a few things. For instance, we are missing the set operators, the union, intersection, and set difference. But we are also missing one unary operator, which is the renaming. So how do we perform renaming? One way is that you can specify an attribute as something else. And that is the keyword. The keyword is S. Okay, so here, within your select clause, instead of specifying AI, you can specify AI as BI. In which case, you are actually going to perform a renaming. Now, there is also another place where you can put this keyword, and that is from the from clause. So if you say that this RI as some other table SI, then you can actually use the name SI as a replacement, as a renaming for that table R. Okay, so there are two ways you can use renaming. So remember, because you can rename the attributes, and also you can rename the table. To rename the table, just rename from the from clause. If you want to rename the attributes, you rename from the select clause. Now, most of the time, if you want to rename from the from clause, you don't actually have to give the keyword. Okay, this keyword is kind of optional if you want to rename from the from clause. So you can actually do this. R1, S1. You don't need to have the keyword inserted over here. All right? So now we have all the operators. We have almost all, because we still have not have the set operation, but we have projection, selection, renaming, and cross product. And this is how it is also mapped. Now, what I want to show you instead there is that to get you familiarized with the SQL query, we can start by doing examples. Okay? So, for instance, I can ask you this kind of question. Find the names of restaurants, the pizzas, and the price, such that the price must be under $20. Okay, so if you want to solve this problem in SQL, you need to ask yourself, how do we deconstruct this problem? Okay, remember that our basic SQL query consists of three clauses: the select clause, the from clause, and the where clause. So you need to answer all those three. Okay, for the select, you need to ask yourself, what attributes do you need to find? Okay, everything is listed here. We need to find the name of the restaurant, and that is our name. The pizza that they sell, and that is the attribute pizza. and the price. Okay, so that is also called as the price. The price attributes. And then you ask yourself, which of the tables contain all this information? Can it be from one table, or must I join multiple tables? Now, luckily for us, this one exists in a table called cells. So all of these are in the table cells. Okay, so now the last thing that you need to ask yourself is, what is the condition that you need to satisfy? And that is, the price must be under 20. So if you can ask yourself this and you can answer it, this will be all your answer. So now, after you ask and answer all these questions, you can now construct the query. Okay, to construct the query, you can just go one by one from top to bottom here, because again, it is already arranged in the order that we had before. So select from where. So we go from the top. What do we need to select? And just select our name, pizza, and price. Okay, and then from which table? From cells. And what is the condition? The price must be less than 20. Okay, so that is what you will get at the end. That is going to be your query. So if you start with the table on the right over here, this will be your output. All the prices are going to be below $20. Okay, so any questions? Again, if we are lucky that this table only has 3 attributes, if it has 20 attributes and you have to list down all of them, then that will be kind of long. Okay, so also luckily that SQL actually provides a way to just specify that you want all the attributes. So like I said before, that is star. You can just say select star, and the rest is the same. So any questions? Okay, so let's have a little bit of demo. To do this, there's a modified pizza.sql over here. You just need to insert this. Because I kind of misnamed some of the things. Like, I think the marinara was named wrongly. So I had to modify that for this. Okay, so we initialize everything first, copy this. Right. Okay, so remember our query, which is select our name, pizza, price. So that's what you will get, which is exactly what we expect over here at the bottom left corner. If you don't have the condition, you will get the table on the bottom right. So select star from cells. Okay? So that's a basic query. So any questions? Okay, so the next one, remember that the condition can actually be made complex. So our condition here was quite straightforward. It's just that the price must be under $20. But we can actually have a more complex query. And in a more complex query, you can actually combine them using the AND operation or the OR operation. So here we have 2 conditions. Either this one is, let me double check. I think I mistyped that. Oh yeah, it's correct. Both must be correct. So condition 1 and condition 2 must be satisfied. Condition 1 says that either the price is under 20 or the pizza is called marinara. Okay, and again, this one has a disjunction. So if you look at it, this is kind of like 1A, and this is 1B. So I have kind of three conditions. So condition 1 must be specified and condition 2 must be specified. For condition 1 to be true, then either 1A or 1B must be satisfied. So how do we solve this? Okay, so again, you can use the AND and the OR keyword. So this is what we want to get. We want to get all the restaurants, all the pizzas, and their price. We can also use the star because this is practically everything from the sales table. Okay, and the condition will be this. Okay, it's kind of complex, but this part corresponds to exactly 1A. Okay, the price is under 20, and this one corresponds to 1B. Only one of them needs to be true. For this one, you say that it's not Diavola. Okay, so this is condition 2. Okay, so that's how you specify. Now, if you're not sure about the order of the precedence of the operation, whether OR goes first or AND goes first, the best way will be to just specify the bracket. Okay, because we say that 1A or 1B must be satisfied for the condition 1 to be satisfied. So you just put them into the bracket so that now there is no ambiguity in which of the ordering it is going to be executed. Okay, so if we execute that, which is this one, and this is what you will get. Okay? The last one here comes from 1B and 2. So it satisfies 1B because the name is marinara. And then for condition 2, the name is not Diavola. In the intermediate, you will see that there's actually one here. This. From Pizza King, there's a Diavola with a $17 price. This satisfies condition 1A, but we don't see it from the final output because it does not satisfy condition 2. Okay? So any questions on this? So yeah, so this is what you will get as you have seen from the demo. Now what we want to look at is how do we remove duplicates. Okay, removing duplicates, you use the keyword distinct. This table R contains 0 duplicates, but you can actually introduce duplicates if you remove some of the columns. If you do projection, and then you remove some of the columns, then certain tuples will be duplicated. When we talk about relational algebra, after that operation, what you will get is that any duplicates will be removed. But in this case, it is not going to be removed. So let me just show you this. Create a table R. So if you just query the table as it is, select star from R. This is what it's going to have. If you remove column B, then there will be duplicates. So select A, B from R. Sorry. A, C from R. Okay, so now I've already removed column B. And if I run this, there will be duplicates. This is duplicates. This is a duplicates. Okay, so this is where it kind of differs slightly from the relational algebra. If you want to follow the relational algebra and remove any duplicates, then what you can do is you can say that I only want the distinct result. And that is where the keyword distinct comes into play. So if I copy this, now I'm only selecting distinct pair of A and C. Notice that all the duplicates are gone. Okay, so any questions on this? So I do have some kind of animation here. If this is what you are doing for Q1, then this is the table that you will get. So that's Q1, contains duplicates. If you do a select distinct, and distinct here is the keyword of interest, then for Q2 you do not have duplicates. All right? So yeah, so what does it mean for two tuples to be duplicates? If for two tuples to be duplicates, we can actually ask more easily whether two tuples are distinct. To check whether two tuples are distinct, what we have to do is we have to check that any one of the attributes, any one of the values from any attributes are different. Okay, so this is the condition for distinct. The condition for distinct means that this either the first attributes, the value of the first attributes are distinct, or the value of the second attributes are distinct, or the value of the third attributes are distinct. So if any one of those are distinct, we say that these two tuples are distinct. Okay, so any questions? Okay, so now again, what happens if I have all null values? If I have two tuples containing all null values, will that be distinct from one another? So how many of you say it will be distinct? Can I see? Can you raise your hand if you say that it's going to be distinct? Okay, so how many of you say it's not going to be distinct? Okay, so it's not going to be distinct because null values, when you check using the is distinct from, two null values are not distinct from one another. Okay, remember we, I think it's from the previous last week lecture, which I think I do have it here. For the part 1. Okay, two null values are not distinct. So yeah. So any questions on this first? Yeah, so that's now this is renaming. You can do renaming by using the as keyword. This is renaming the attribute name. Okay, so we have a few kinds of renaming. Right? We can rename the table name, we can rename the attribute name, or we can rename both. This is just renaming the attributes. And in fact, this is not even an actual attribute. What you can also see is that you can actually perform computation on the attributes. Okay? So if you perform a computation on these attributes, what you will get is you will get the actual value from that. The quantity multiplied by the price. And then you do the renaming. So I need this. Let me drop the table first. so that it doesn't clutter. Create the table orders, and then this is the query. This is what I'm going to get. Okay, so notice that for item A, the cost is the quantity times the price, which is 250. And it becomes a numeric value. And also for the rest, it becomes 400 and 750 because you just multiply the two values. Okay, so that's what you get. You can rename, and you can also perform simple operations based on the values of the attributes. Any questions on this? You can also do concatenation. This is the operation for string concatenation. Okay? Yeah, I mean, unlike many other programming languages where you actually have a plus for concatenation, SQL uses the double vertical bar. Okay, and this might be slightly confusing if you come from other programming language because this is typically an OR. But yeah, so just remember that this double vertical bar is actually concatenation. So what you will get here this underlined queries, what you will get is that you will get this long string. Price of Diavola is something. Okay, so I can give you an example over here. Oops, forgot to copy this. Okay, so that is what you get. Most of these come from concatenation. Okay, Diavola comes from the attribute pizza. This comes from the computation of the price multiplied by divided by 1.3, and then you round. Okay, so that's the rounding function. Any questions? So yeah, that's basically almost everything from this lecture 3, the second part of the lecture 3. This is the summary. And let's just have a quick 10-minute breaks before we continue with lecture 4.
How do you do something like this for SQL3? How do you like combine two tables, two of the same table?
Then you do
How do you rename? How do you rename?
Oh,
The two of them.
Remember that you can do the cells as something.
Yeah. So
Then you rename the table.
yeah, but then the attributes inside.
The attribute will be the same, but
How do I differentiate?
you can differentiate the attribute by using the dot notation.
Okay.
So if you want the attributes of pizza from cells, you can also use cells dot pizza. And after you rename cells to S1, let's say, you can use S1 dot pizza to differentiate between another kind of
So
cell.
within the same SQL statement, when this one sells as S2, then I can
Yes, you
put
can use
S2 in
S2.
the same statement.
Yes.
Okay.
We're actually going to go through that when we talk about join.
Okay. Okay.
It's not actually written, but if I don't put language here, then what? Will you just assume R?
Actually, it's a good question. I'm not exactly sure what it's going to give.
Oh.
I've never tried. Again, the good thing is that we can always try. Some simple possibilities is that it may just fail. You unknown.
Okay. Alright. Thanks.
Can I ask whether we can have the answer for the tutorial quizzes?
You should discuss it in the in the forum.
Okay.
Yes.
Just
So if you're not sure, try to discuss it in the forum.
because it's like you don't know whether you are sure or not, and you don't
Yeah.
want to just list out every single. So it will be more efficient if we can get the answer. Then we see the answer, we know like if we are not sure.
Unfortunately, because that one was also used as a quiz, an actual quiz, but I do not want to give an in-class quiz because the luminous is not exactly that stable right now. So when you're using IVL, you can kind of give that as a quiz.
Okay.
So-
Okay. So the
yes.
answers cannot be.
Yes,
I see.
unfortunately you cannot. But what you can also do is you can give your answer first in the forum, and then maybe someone will reply.
Sure. Thank you.
For project assignment, I want to ask whether is it possible to use like ASP.NET to do?
Sure. You can use anything, but it's just that for the guide that I'm giving, because I'm trying to minimize the amount of new programming language that you need to learn, I'm giving you Node.js. Yes, you can use anything.
It's from the cross product because by right from is only taking from one table. Right?
No, but you can specify multiple tables.
Oh, do they have to use like joints and stuff? Like
No
those
need.
and all? So if you specify multiple tables, then
It's-
you get return
It's a
and function.
cross product, yes.
Oh, okay. Got it.
Okay, anyway, before we start, there's a few questions here. because I did not really have an example for that. So a few things that we did not fully address is renaming and the from clause, and the cross product. I already removed R, so let's look at R here, or let's look at order here. Okay, so this is my order. No, wait. I need to drop it first. And then recreate it. Okay, first, you already know renaming of a column or attributes. How do we rename the tables? Okay, so you can rename the table as order 1. This will rename the table, but all the attributes remain the same. Okay, but of course you cannot really see it here. The other thing is that if you want to rename an attribute, instead of renaming an attribute, you can also actually access that attribute using the dot notation. Okay, the dot notation is basically you have the table dot attribute. Okay, and this is good if you have a conflict. If you have two, if your table after the cross product produces the same attribute name, but they come from different table, then you can specify which of this attribute you want by specifying which of the table it comes from. So, if I'm going to just rename the table from orders. Okay, so again, before that, I can actually remove the S keyword. I can just say O or O1. Okay, if you want to rename the table, you do not need to use this keyword. This keyword is optional if you are renaming the table. So this is what you get. So again, you can't really see the table name. But if I do this, what you have now is that it will be, there will be a cross product. The cross product means that each of these attributes will be duplicated. But the first set of attributes will come from O1, and the second set of attributes will come from O2. So you will get this. Okay? Now again, you don't really see it here, but if I want to say, I want this. I want this second column only and the last column. I can then say that what I want to select here is O1 dot price. And the second thing that I want to select is O2 dot quantity. Okay, there is no ambiguity on where it comes from. Okay, but of course they are the same. But if they're not the same, it makes much more sense. Okay? So yeah, and also notice that there will be duplication. Right? So that's cross product and renaming. We will talk a lot more about this when we discuss join. So cross product is kind of a join. For the concept that I'm going to talk about in the lecture 4, there are many different conventions around this concept of ER diagram. We're going to use one of this. So I'm just following from the previous semester, which was following from the previous semesters. It has a kind of unfortunate side effect that for almost any ER diagram tools that I found, they're following a different convention. Okay? But in your project report, you can just use any of these tools, but just make sure you note that what kind of mappings do you use. Okay? So you will notice that if you find a tool, a free tool, you may find that certain lines are different. Okay, they mean different things in different tools. So if you're using a different types of lines, just make sure that you specify what does that line mean. Or if you use a kind of arrow, specify what those arrows mean. Okay? So in your project report, please do that. Okay. So we'll just skip the recap. So our overview for today, I think we may only have time for the first part. We don't really have time for the ER to SQL, but there should be enough for the next tutorial. Okay. So the first part is about the entity relationship diagram itself. Okay. I know it's kind of like jumping around because you start with a relational algebra, which is the mathematical description of what it is. And then I'm giving you the SQL code together with SQL query on how to create the table, how to query, and so on. And now we're jumping again into how do you design your database using diagrams. And what can you capture with this diagram? So this is a basic conceptual model developed in 1976. It can capture a lot of the constraints. In particular, it captures primary key and also certain kinds of foreign key. So this is on this part. So when you try to design your database for your web app or for your project, you need to do the requirement analysis and then you follow all this. Okay? If you want to know more about the physical database design and the application and security design, you need to get into the more advanced module. I believe for the 5 here, point 5, is the CS3223 or CS3233. I forgot which one it is. This one is probably some information security module. We're going only to touch a little bit about simple security attack that you can do on database. So on the very first part, you may get something like this. Okay? So if any of you have read the project description, I'm giving you something like this long paragraph, which contains specifications. Okay? So if you have read this, good. But if you haven't read this, we're going to go into more details later. But how do we go from here to an actual table creation, to an actual schema, and how you can use that for your web app? So let's start with the basic of ER model. This is the basic shapes that you will see. There are lines, there are rectangles, there are diamond, and there are oval. Okay? So the rectangle specifies what we call as an entity. Entity is kind of like your instance of an object. And if you have a set of those objects, an instance of an object, in an OOP language, you can have an instance of an object that corresponds to an entity. If you have a collection of those, you can describe those with a class. So the class is your entity set. Okay, attributes are in the oval. Okay, and so the entity sets are those in what is in the rectangle. So the entity itself is an instance of it. It's your tuple. We can specify the key. In particular, the primary key will be underlined. If you have multiple primary key, you underline all of them. So if this one is also a primary key, which means your primary key is now a pair of attributes instead of a single attributes, you underline all the primary keys. Okay? So what it also means is that you cannot know which are the candidate keys from your design, because you can only mark one of them. Okay? So yeah. So you can only note one of the candidate keys, and that will be chosen as the primary key for this. The relationship encodes kind of a relationship between two entities. Okay, and that is given in the diamond. If it's too long, I'm just putting it as a 2 lines like this. I tried to make it in 1 line, but the PowerPoint tools is not exactly that good for that. So yeah, so again, relationship encodes what are the relationship between two entities. So each of these may correspond to a table later on. So if you look at the description again, we try to mark every entity with orange, every relationships with blue, and every attributes with green. There are other possibilities, but some of the possibilities that I'm going to give you are going to be this. Customers is going to be an entity. Okay? So if a customer is an entity, what should be the attributes for customer? Okay, customer, it says that they often pay by credit card, so this is possibly an attribute of an entity. Okay, it may not be, depending on your design. Okay, then you must have a customer identification number, and so on. Okay, and then probably name and address. And then the other possible entities is books. So this is the first entity. The second possible entity is books. And then it has kind of the usual one, ISBN, the title, the author, and so on. One possible relationship will be place orders, okay, which is here. Now once you have identified all of that, and you are kind of satisfied with your design, then you can actually draw it out. You may get something like this. So again, this may not be the only solution. And in fact, this has a kind of limitation. Okay, so before going further, you can actually kind of see what kind of limitations this design entails. First, we say that ISBN here is a primary key, okay, which is good because no two books will have the same ISBN. If they differ in any one of those, if they differ in author, if they differ in title, or even for the same title, if they differ in edition, they will have different ISBN. Okay, so ISBN is indeed a good choice for a primary key. But what it means is that every book with the same ISBN must be sold at exactly the same price. If you have multiple bookstores, because it's not captured in this diagram, if you use this in a larger context where you have multiple multiple bookstores, then every bookstores, if you're using this design, must sell that same book with exactly the same price. Okay? Which may not be a good design. So again, it depends on what you want to do. So yeah, so there may be certain limitations on your design. But in this particular instance, because we only look at one particular bookstore, this design is sufficient. So after you look at the design, you can actually try to add more and more constraint. The kind of constraint that you can add is, there are two mainly. This is the key constraint and the participation constraint. But before we talk about that, we haven't talked about the lines. So again, this one, the oval, is the attributes. The rectangle is the entity set. The diamond is the relationship set. Now, if you have a line over here, or here, or here, the meaning is kind of straightforward. It means that that attribute belongs to that particular entity set. But what does this two lines mean? Okay, so what it means is that this customer is related to that particular book with this relationship. Okay, typically, we want to make it such that you read from left to right. Okay, so the customer places orders on books. But you can also try to read it from right to left, which is this book is being ordered by this customer. Okay, it does not enforce any kind of a direction. So then the lines here, we can put constraints on it, such as how many customers order the same book, or how many customer can order the same book, or can customer more, and can the same customer order different books, and so on. So that's what we meant by the key constraint or the participation constraints. If you do not have anything, if the line is just a plain lines, it means that there is no constraints. This is what we call a many-to-many relationship set. It means that 0 or more students can enroll in a course. All right, so for this particular one, student enrolls in a course, you don't have any restriction at all. A student may not enroll in any course. Okay? A course may not have any students enrolled in it at all, as you can see from these two examples. Okay? So if it's just a plain lines without any bells and whistles, it means that the constraint here, you can think of it as greater than or equals to 0. Okay? So if you want to put a key constraint here is that there is at most 1. Okay? And this key kind of corresponds to your foreign key and your primary key. And in fact, the way we can enforce this is a combination of a primary key as well as a foreign key. But what it also means is that you look at this part. So, okay, so the student here, this is the differentiating factor. Instead of having a plain lines, what you have is an arrow. Okay, so the student here is constrained. You must have at most 1. So here, this is a plain line, so you have greater than or equals to 0. This is an arrow from student to supervisors. It's an arrow, so what you have is less than or equals to 1. That's what it means by a key constraint. Okay, so if you look at this component, there's only exactly one line at most, but it may not have a line at all. It is possible because, again, less than or equals to 1. 0 is less than or equals to 1. Okay? So any questions so far? Now you can also kind of make it a one-to-one. A one-to-one constraint just means that both entities that are involved in that relationship will have a key constraint. So every student can be involved in at most one project. And every project can only be worked on by at most one student. So again, that constraint specification holds, less than or equals to 1. Right? But again, 0 is less than or equals to 1. So you can have projects without any students, or you can have students without any projects. But what you can know is that if a student is doing any project at all, that student must be doing exactly one project. Okay, so any questions? And so far, all the relationships that we have talked about involve only two entity sets. But it need not be two entity sets. It can be one, or it can be more than one. Okay, so again, before we talk about this, let's talk about the many-to-many relationships set. There are other properties here that is of interest. So we talk about this. The one in orange means that courses may not have students at all, and students may not be enrolled in any course. But we have not talked about this enrolls part, the middle part. If there is an entry in the middle, okay, so the grade here corresponds to the entry in the middle, so this is the grade. If there is an entry in the middle, for every one of those entries, it must connect exactly one on the left and one on the right. Okay, so can you all see that? Every single one of this connect 1 to 1. You do not have this branch out. Okay, so that's what it means. But it doesn't mean that the value cannot be duplicated. So let's erase all first. The value in the middle can be duplicated, as you can see from here. Even if the value is duplicated, they must be connecting different entities. One of them, either the one on the left or the one on the right, or possibly both, must be different. Okay? So that is one of the critical points here, because when we talk about this constraint, we usually talk about it in terms of the entity sets. But we never really talk about what happens with the relationship set itself. Okay? The relationship set itself must satisfy that particular condition. If a value exists, it must connect exactly one on the left and one on the right. Okay, but the value can be duplicated. So yeah, again, that is still satisfied by this, one on the left, one on the right. You will not have any branching at this particular point. So again, here, you do not have any branching at this particular point. Okay? Which means that for a three-way relationship like this, every element over here must connect exactly one from each of the involved entity. Okay, you cannot have a duplicate of that triples. But you can have a duplicate of any of the pair. So Alice, I don't have an example here, but, oh, actually I do have. Alice, no, actually I don't have. It's quite hard to see. But you cannot have Alice working, for this one, you can actually have Alice working for both IS and CS in the same building. Okay, so any of the pairs can be the same. Alice can work for both IS and CS. Which means that if Alice works for IS in Com2, Alice may also still be working for CS from that same building. As long as one of the three is different, it is allowed to exist within that relationship set. Okay? If you do not have that building, if the building is not involved at all in here, it means that Alice cannot work for different departments, may not be able to work for different departments, okay, depending on whether it's allowed or not based on this. Okay? But even if this one is a one-to-one, okay, so if it's a one-to-one like this, okay, so one-to-one between professors and departments, it means that Alice cannot work for different departments if there is no building. But Alice may work for the same departments as long as Alice is in a different building. Okay, so as long as one of the three is different, it is allowed to exist here, even though this one is one-to-one. Okay, so let's give a concrete example. Erase everything first. Modify this slightly. Assuming that this is one-to-one. Okay, so assuming it's one-to-one, we have multiple cases. One is that if there is a building component, if there's a building entity set in the relationship, then what it means is that Alice, okay, so this one is, there is a building. Alice can work for IS in one of the building, and Alice can still work for IS, but she must work in a different building. Okay? So yeah, but if there's no building, then this one is not going to be allowed at all. Okay? So anyway, most of the time, the n-ary relationship constraint is only used if you really, really need to have it. Okay? It makes things a lot more complicated. You can try not to have it, but sometimes you're just going to be forced to have it. I can tell you that for midterms or finals, I can always force the design to have such a thing. All right? So yeah, so try to be familiar with it. So any questions about this first? The other thing, besides the key constraint, is that what we call a participation constraint. Okay, so remember, for key constraint, what you are interested in is less than or equals to 1. The participation constraint is the other thing. It means that it is greater than or equals to 1. If you are forced to participate, that means this is the constraint, greater than or equals to 1. And is it actually feasible? It's marked with a double line. Okay, the print itself might be small, but it's actually a double line. It is something like E1 R. Okay, so it's a double line. Okay, and that's a participation constraint. It means that it is greater than or equals to 1. It must be there. Okay? So, again, this one is a partial participation constraint. It's basically unconstrained. So, normal line, greater than or equals to 0, greater than or equals to 0. If you have a participation constraint, this one is greater than or equals to 1, while this one is still greater than or equals to 0. The main thing here is that this must be involved. It must have a line connecting to the middle one. Okay? It cannot have any entity that exists here that is not involved in the enrolls. So yeah, but again, on this side, you can have a course that does not have a student. Now you can combine both the participation constraint with the key constraint, and what you have is a key and total participation constraint. Again, what it means is that this one, if you look at only the arrow specifies that this one must be less than or equals to 1. The double line specifies that it must be greater than or equals to 1. And the only solution for this is that if it is exactly 1. So you see, all the entities here is involved in the enrolls, and they are involved in exactly 1. All right? So any questions? So now we have an array relationship, which I gave you the 3-way. You can actually have a relationship involving only one entity set, but it must be involved at least twice. Okay? And that is something like this. A student may mentor another student. Okay? And there is a role in this. So the student mentoring the other student is the senior. Well, it means that the senior is mentoring the junior. And the direction is actually implicit, is based on your understanding of the diagram itself. Okay? If you just look at the diagram, it doesn't really say which one is mentoring which. I can also have the junior is mentoring the senior, but it is more unlikely scenario. But again, the diagram itself does not specify that. What it says is that there's a role, and one of the role is the senior, and the other role is the junior. Okay? So that is if it involves only one, but it must involve multiple times. The other kind of constraint that we can have is what we call a weak entity set. Now this is special. The weak entity set, by its own definition, it does not have its own key. So if you look at this, a chapter in a book, if you want to represent it as its own entity, it does not have its own key, because the chapter number may be duplicated. Almost every book has a chapter 1, right? Unless you rename it to something else. But almost every book will have a chapter 1. Okay, so you cannot just identify a chapter by its number, but it must be identified together with the book itself. For this particular book, its chapter 1 is unique. So that's what it means by weak entity set. Now another kind of example is a dependency, where an employee can have a dependent. Okay, so if you are a foreigner in Singapore, if you work with a EP, you can have your children living in Singapore, and they're living using a dependent pass. But for them to stay here, there must be an employee first. So the key of this is a weak key where they must depend on the primary key of the identifying relation. I forget the name. The owner entity. Okay? So that's what a weak entity set is. Its own key is too weak to actually uniquely identify its other attributes. Because it's too weak to uniquely identify its attribute, it must depend on the attribute of the owner entity. So those are the two possible examples. So a book chapter, the chapter number depends on the book primary key. Because every book will most likely will have a chapter 1. Okay, so dependents, two people may have the same name, but you can identify them by the parents, assuming again that the parents are not weird that they name two of the kids the same name. Okay? It's a kind of a almost guaranteed assumption. But if it exists such a way, then I don't know, maybe we need to sue the parents or something. But yeah. Okay, so that's basically the ER diagram. So I'm just going to leave you with the summary over here. And I'm going to give you another kind of notation that may help you in remembering this. So many to many, the easy way to remember is greater than or equals to 0. Key is less than or equals to 1. Total is greater than or equals to 1. Now you don't really have to remember key and total because you can just combine both of them. It's less than 1, it's less than or equals to 1, and it's also greater than or equals to 1. It must be exactly 1. Okay, and this is how you identify a weak entity set. The weak entity itself is the one with the double lines. The identifying relation is the relation with the double line. Okay? And there's a special rule. It says that it's the lines itself is a special lines. It's a key and total participation. Right? So this involvement over here is exactly a key and total participation, which is greater than 1, less than 1. Okay? And it kind of makes sense because every book will only have exactly one chapter 1. Okay? Actually, most books. I'm not sure whether there are any authors who want to have multiple chapter 1s. But most of normal authors will not have multiple chapter 1s. All right? So yeah. So that's your diagram, a diagrammatic design of your database. So any questions? Next week, what we're going to look at is how to transform this diagram into SQL query. So you will get a lot of this. It's just going to be a mapping. Okay, so if there's no questions, then I'll see you next week. Yes?